Hello and welcome to today's webinar, which is the first of a series of webinars on Metaverse. I'm Ali Emdad, Associate Dean and Director of the National FinTech Center at Morgan State University. I also want to thank the outstanding panelists, Raphael Brown, and Sandy Agarwal, who spent many hours with us over the past several weeks to plan and arrange this series of informative webinars. In the first one, we will review the vision, history, orientation, and components of Metaverse. And then in the future sessions, we will have discussions on identity, avatars, privacy, rights, ethics, play, education, games, sports, simulation, and social media. And then we move on to commerce, work, legal aspects, and tools, IP, and also finance. So without further ado, I would request my colleague who was instrumental in organizing this webinar, Tynisa Walters Brown, to introduce our panelists. Tynisa?
Thank you, Dr. Emdad. First, I would like to introduce Mr. Sandy Agarwal. Sandy Agarwal is a technology leader with expertise in systems development, enterprise and architecture and systems integration, and product and program management. He has many years of expertise in rolling out bank technology platforms such as trading systems, reference data management, customer regulatory reporting, cash management, and payments. Sandy is also actively involved in the FinTech and blockchain space via open source community projects with Hyperledger in the financial services and gaming special interest groups, and is currently working on developing solutions to reduce DLT friction in FinTech and games. Our next panelist, Mr. Raphael Brown, is a game designer, game developer, XR technologist, and studio head. He is a 25-year veteran of the game industry who traces his roots to Looking Glass and seminal FPS Thief. He saw this generation of virtual reality start on John Carmack's desk 11 years ago while working on the open world FPS Rage. Raphael loves building virtual worlds. He has been dreaming of the metaverse since watching the Tron in the theaters as a kid and reading Neuromancer a couple years later. During the pandemic, he founded Symbol Zero, which builds games, virtual worlds, virtual concerts, and cloud platforms. Symbol Zero is Roblox's virtual concert partner, having built the Lil Nas X virtual concert experience, the second largest virtual concert in history, and many other concerts for Sony Music and Warner Music and Roblox. Last but not least, I would like to introduce Dr. Marav Ozair. She is a global leading expert on blockchain and cryptocurrency with a background of data scientist and quant strategist. Currently, Dr. Ozair applies her unique expertise to researching and investigating distributed ledger technology and blockchain ecosystems, digital assets, crypto markets, and specifically decentralized finance, DeFi, and non-fungible tokens, NFTs. She has been developing innovative methodologies to evaluate digital assets, crypto markets, including cryptocurrency indexes, valuation and risk metrics, ratings and tokenized products, and of particular focus, researching various DLTs and DeFi solutions, including decentralized identity and decentralized trust, privacy, and security, mainly through consensus mechanism protocols and governance, including decentralized autonomous organizations, DOAs, of the platform application. Dr. Ozair is a FinTech professor at Rutgers Business School. At RBS, she has developed and teaches courses on blockchain and digital assets for both undergrads and graduate level, and is the research director of RBS Blockchain Hub. She serves as an advisor and researcher at the Rutgers Blockchain and FinTech Collaboratory and is affiliated professor at Rutgers Law School, focusing on DeFi. Without further ado, I would like to pass it over to Dr. Ozier. We're going to unmute you.
Yeah. So good afternoon, everyone. If you are based in the eastern side, and if you are in the west side, probably that's a good morning to you. So I guess what I'm going to start with is a little bit of a brief introduction of, I don't know, 8-10 minutes to introduction of some definitions of, just so you have an understanding of what is the metaverse, Web3, and how everything fits in. So I'm going to go through that quickly, and then I'll give the stage to my esteemed panelist here. So let me share my screen and go over like a brief, overview so you understand where everything fits. Let me see if I can share my screen. Yeah, okay. So let me do that very quickly. Let's see, I'll share my screen. Okay. So I hope everyone sees my screen. Can you see my screen? Okay. So yeah, so we are basically now in our first of the first seminars, not seminars, sorry, webinars that we're doing in on the metaverse. So we have to start, first of all, where everything fits and what does it mean, the metaverse. So I like to start with a very broad overview, macro overview of where everything fits. And if you think about the metaverse, I mean, people now think about all the hardware, like the VR, the virtual reality, the augmented reality, the goggles and all of that. But, but this is not the only thing. That's probably what people perceive, because that's what they see probably in, I don't know, kind of science fiction movies. And that's kind of like people having their mindset. But in any event, the metaverse, in order for that to really function and become what it's supposed to be, what we envision, then there's a lot of things that has to come together. And not just, the VR and the AR, which is virtual reality and augmented realities, but a lot of other technologies like we're talking about, artificial intelligence, Internet of Things, and of course, blockchain. And this is, comes with Web3. So in order to put things in the right context, and of course, with blockchain, we have all of those things, where people already, talk about, how NFTs, relates, to the metaverse. And you probably heard about Decentraland, maybe yes and no, but, it's all about, each and every parcel is basically NFTs. It's how we authenticate that. We're talking about transaction, how you're going to make transaction in the virtual world. You need virtual money, and this is, we're talking about the transaction that will, have like decentralized finance. And of course, there are all kinds of issues that we're going to talk about that relate to the security and the privacy of the metaverse, and how it will be governed, maybe to go through a decentralized autonomous organization. And there's also many questions about interoperability, which means, how all these virtual spaces will interoperate with each other, are they? Because each and every one of them will be in a silo, but, in our life, we know that we like to move and interact between different spaces. This is how we used to in our physical life. So, in fact, I wrote about, I have articles you can find on my website even, and I'm sure that it was shared with you, all kinds of articles that I've written about each and every topic here. But first and foremost, I would like to explain more, what is the metaverse and what is Web3, because there's a little bit of a misconception. Many times, the metaverse and Web3 are being used interchangeably, but they're not the same. As you can see, I didn't put them as one. So let's look at what does it mean. And in fact, Web3 is more connected to the blockchain, and blockchain within the metaverse. So let's understand first about what's, how to think about and what exactly is the metaverse and what exactly is Web3. So this is just, a very broad bird overview of where everything comes together. So let's start with what is Web3. So Web3, broadly speaking, Web3 is the evolution of Web2, meaning the internet that we know today, what we're using right now, right? We have this meeting on Zoom, and what is Zoom if not basically, what we're talking about? This is our internet. This is our Web3 type of internet. But it is a centralized internet, right? Because it is owned and controlled by all kinds of centralized company. And the move to Web3 is basically a move from centralized internet to a decentralized peer-to-peer internet, where no one entity claims control. So it's not controlled by one entity, like one company, whether it's Meta, formerly Facebook, or the Google, or the Apple, any of those, big technology companies, but rather it is decentralized peer-to-peer. So more specifically, the concept is basically the next generation of the internet. So it's the evolution, from, what we have now to something that is more decentralized. So it's how we're thinking now. We kind of the idea is basically to give the control or the ownership to the users rather than to the centralized companies who own, whatever the data and everything else. So the control now of the creation of any content, any digital assets will be of the users. So unlike, in Web2, when all these centralized companies, and you probably heard about the, this Cambridge Analytica incident with Facebook, that they took the users, information and sold it to, they can sell it, to marketers and everything else. Because why? Because the internet now, in order for us to tap into the internet, we have to go through those centralized companies because they provide this service. But if it is decentralized and it's not owned by anybody, there's no one entity that claims control, then basically that is how we can create the right protocol that this data will be controlled and owned by the users. And the users that create the content, they own their content, they control it, and they have the ability to monetize it through the implementation of blockchain technology. Now, and this is the relation to blockchain technology, how that come to play within all this ecosystem, including the metaverse. So let me just give you a brief understanding of what is blockchain if you haven't already taken a course in blockchain. But if you haven't, then just very briefly. So what is blockchain? When we think about blockchain, then most simplicitly, people think about, oh, blockchain is a ledger. Yes, it's a ledger, but it's not really like a ledger like, like Excel. It's not even, a more sophisticated one like, the SQL, like what we have with so it's not even that. It's much more complex, So I'm saying that yes, it's a ledger, but it's not. I mean, it's the data structure and all of that. It's much more complex, but you can definitely and this is what providers and also what I do is taking this information and putting it in a more something that is easy to read. So yes, it's a ledger in the sense that it records every transaction, everything that is recorded. But it's not just a simple ledger. This is an immutable ledger. What does it mean, immutable ledger? It's meaning that everything that is recorded, unlike with Excel or even SQL, it is something that cannot be changed. Once it is recorded, it stays there forever. You cannot change it. You cannot alter it. You cannot come and delete it. Whatever, if you want to make a change, and you have to create like a counter, transaction. If you want this transaction to, you say, oh, I didn't mean to do this, so you have to create like a counter transaction, but that's not always feasible. So there's, other, issues that relate, to and that what, people are trying to understand how that can evolve. And I know that there are a lot of coaches that are working on that, but that's for a different day and a different topic and a different webinar probably. But just so you understand what we mean about blockchain and the concept of ledger. At the core, it is a decentralized ledger, meaning that everyone has a copy and everyone have access to this ledger. Again, as long as you have internet connection, it doesn't matter whether you are, everyone around the globe, whether you are on the top of the Himalaya or selling on a boat to Alaska, it doesn't matter where you are. As long as you have internet connection, you can tap into this ledger, this blockchain, and you can have a copy, you can see everything is inside, and you can even engage in the validation. That's what you're talking about, let's say, the validators. So this is why I said it is cross-border. So in just, briefly, because conscious of the time that we have here. So if I summarize, what are the main features of a blockchain, it is centralized, it is mutable, there's no central authority, it is trustless, meaning there's no intermediaries, and the way that we achieve this trustlessness is through this validation mechanism, which is not, again, I'm not going to go too much into that. It is anonymous, but I would like to call it semi-anonymous, pseudo-anonymous. And pseudo-anonymous is because you see all the transactions, but you do not know, the right identity of this address of the account. Like it sounds like, if you go to a bank account, we said ledger, right? In a bank account ledger, you have the account and you have the information of all of the identity of this account, right? Whether it's social security, and you have and all the, even maybe a name, an address, and all of that. You don't know that when you're looking at, information that comes from the blockchain, because this information is basically, all what you have is a hash, meaning some kind of number. You can call it, for the sake of simplicity, like the ID of the account. But other than that, you don't know who that person or persons is, and you don't know anything. So it's, yes, everything is transparent, but the identity. But again, I can tell you, and I'm doing my own analysis now. I'm working on developing a product which does all kinds of tracing and mapping. I don't want to go too much into that, but it is possible even to identify those. So not going too much into that, but it's cross-border, peer-to-peer system, and the way that we might think about it is a democratic system run by the people for the people. And this is in fact how it was first launched. The Bitcoin, blockchain, which people kind of forgotten what that means. This is how everything basically kickstarted, with this concept of for the people, by the people. But that's for, again, a different day, a different webinar. So a little bit about what is the metaverse. I already mentioned that a little bit. So the metaverse is basically a virtual space, and this virtual space will merge and integrate in our lives. Like the idea is that it will integrate to any aspect of our life. When we're talking, whether we socializing, working, entertainment, learning, education, it's like it will be everywhere. I mean, even Bill Gates is already talking that in 5 years from now we're going to work in the metaverse. I don't know if this is physical, 5 years, but the idea is that we can do a lot of things. I mean, everything that we have in our physical world we can do in the virtual world, and of course we can engage with people from not only in our community but all over the world. But that's that's a big concept, and big idea. And something that we shouldn't forget is that this big, grand concept is not a complete reality yet. Yeah, people are saying, oh, but there's a concept in the metaverse, or even there was a standard, a bank, a Spanish bank, did awarded some for their fintech I think competition, did something in the metaverse, yeah, because they have, I think, a partial launch in Decentraland. But again, it's not exactly the metaverse that we super envision. It's still not there yet, but people are using this terminology, so you have to understand that the big concept of what we kind of envision sci-fi movies is not there yet. So this 3D immersive world that we're talking about That's what it's supposed to be. We're not really there yet. In Quebec, as I said, a combination of a lot of technologies, from virtual reality to augmented reality to mixed reality to gaming, cryptocurrency, social media, and all of artificial intelligence, Internet of Things. So a lot of technology will be coming together to create this. So in other words, is metaverse is basically a way to think about it, that when the internet, transformed from 2D, that's what we have right now in Zoom, in a 3D. Suppose that now, if we have this really, this, vision of this reality will come to fruition, then we're gonna have this webinar in a 3D type of thing, like as if we're sitting in a room, in a conference room, or a big hall, a lecture hall, and we having this webinar. So that's how you kind of envision that in this virtual world. So instead of browsing or interacting in the 2D, each and every screen can become this 3-dimensional one, and users can walk around inside the page and interact with other users' avatar and all of those things. In fact, what we are just doing right now, which is 2D, we can be like in a 3D type of thing, as I mentioned. And now I will end with basically the relationship between the metaverse and Web3, which I started with because there's a lot of misconception, and sometimes people use that interchangeably. So the way you can think about it, the metaverse can be either centralized, owned by Meta, which is formerly Facebook, which is the same basically. Zuckerberg is saying, oh, I'm gonna rule the world, so to speak, and I have Meta, and everyone is going to interact in our metaverse, or it could be decentralized. So if the user's ownership is prioritized, if we really believe that the user's ownership is a priority, then it is important for us to implement the metaverse in a decentralized way. And in this way, we can achieve, and this can be achieved by the set of rules and guidelines of the Web3, and which will provide us, it gives, the ownership, so the users that creates the content, they will own it, they will control it, and they will be able to monetize it. So this is my part of this webinar, and now I will give it back to Professor Emdad to take us to the next panelist. Thank you very much.
Thank you, Merav. And now it's my pleasure to introduce Raphael Brown to discuss vision and history of Metaverse with you. Raphael?
Great, thank you. I'll be giving an abridged version of this to fold in ideas from a larger lecture. So I will, let's see here. I will start by just actually diving into my slides. Some of these I'll breeze past quickly as there is a larger lecture, but I hope you guys enjoy them. Perfect. Okay. So who am I? I'm a game designer. I build virtual worlds. And why do I care about the metaverse? Because of these things. Tron, Burning Chrome, and Snow Crash. Because science fiction, folks have built up a vision of a thing that I and many others have been building towards for decades, and because we see it as a very real next step of computing and online interaction. So what I'm going to do is just show you a quick grounding. I'm not really going to go into these, but where did this come from? Virtual reality has been around for a long time. I won't go into that now, but that notion of virtual reality was borrowed first by William Gibson and then Neil Stephenson. They created a vision that many others have added onto, both in fiction and in the real world as we've tried to go towards it. That has carried into a great many films, into animation, pretty much into every creative expression and of course into games. But it's this idea that we can make a 3D spatial successor to the internet, that people saw what the internet was becoming and they thought about what could be after it. So what we're going to try to do is give you guys a grounding in this metaverse vision and how to get there. So first of all, it's important to understand the rise of the internet. So internet history goes back to ARPANET and to early notions of connecting computers that have been around for a long time, basically since the 50s. We've had this sort of slow, steady progress as we have gotten to a rise in the semiconductors and transistors that make this all possible. It's all about silicon. It's all about the hardware. And with computers, it always has been, and that's okay. We are tool users. We're basically monkeys with smart brains, and we make tools. And the tools that we are most good at are computers, because they are our second brains. So what does that mean? There's a lot of information here, but I'll distill it down for you real quick, which is essentially that ARPANET is a thing that started as a notion in the late 50s, was developed really in the 60s and 70s, that then started to make way to Usenet and BitNet. And while Usenet and BitNet were being built, people were coming up with the standards in the 80s for the internet. You also had what were briefly called the big three, which were CompuServe, Prodigy, and AOL, which started to show product in the 80s that allowed people to go online before the internet. And then in the early days of the internet, and then that led to the web. So the web then is not the internet, it is the thing that became most popular on the internet. And for a while, and gradually it's being supplanted by other things. So things like what? So first off, sitting alongside the web, we've had FTP and IRC and email and Gopher and Telnet and other things, and bare metal servers and games running on those. And we've always had a wide range of activity. But that started to change as things became more formalized, as there was enough computing power and effectively enough silicon for industries to grow up around that. And the first thing coming after the web was cloud. As a notion in the late 90s, launched in 2002, and now the thing that runs most of the servers that run most of the services that you use every day across things like Amazon AWS, Microsoft Azure, Google G Cloud, IBM Cloud, but also Tencent's Cloud, and a host of others around the world. Then blockchain came up in 2008 and was popularized with the release of Bitcoin. And these two things have been chugging along for a good long while, along with Edge. But I want to kind of dive into what the internet means. The internet is a thing that effectively started in the late 80s, where usage was small for a good long while. And if you look at the growth of the internet, the interesting thing is that where it really hit its stride, it was being used steadily by small groups of people for the 80s and the 90s, but where it hit its stride was right around the turn of this last century. At 2001, you've got 50% usage in the US and in similar developed countries. But the interesting thing is that by 2021, 10 years later, we are at peak internet usage in much of the developed world. But the interesting thing about that is that 20 years later, the developing world is at about the internet adoption that the developed world was 20 years ago. Now, it's very possible to debate, develop, and developing and develop. But the point is, we are at one peak of internet usage now, there will be others. More people need to go online, and more people need basic internet access before we can get to a metaverse. What we are doing mostly now is we are figuring out what computing devices can get people online and getting those to people at a price point and a function that they can use them. And that process is still ongoing. It's very important to understand that it's not just, oh, everybody went online. No, there are waves of people going online. And this is still happening and still needs to happen before we can be talking about a future thing. How does the metaverse grow? Well, if you look at the internet, in the 70s and 80s, there were ideas being built and planned and experimented with prior to the launch of the internet, and those things need to happen now. Those conversations have not happened yet, but they're just starting to. In fact, I just saw a SIGGRAPH panel that was talking about protocols that had everyone from Epic to Adobe and others all in between. There is no consensus. If anything, there are multiple competing groups, and we're still trying to figure out what the shape of that next thing should be. But the important thing is that we have a lot of work ahead of us, and it's not just, oh, let's put everybody online. It's that in order to do that spatially, we need about 1,000x the computing power, not just of individual computers or cloud or blockchain, but every device and switch and router needs to be orders of magnitude greater, and that just takes time. And so there is likely no backwards compatibility between the now and the future, but instead there's a gradual deprecation in the same way that things built on ARPANET and Usenet and BidNet did not carry over to the internet. This is important. It's good to let go of things when we're building technology and not to assume that everything stays. It doesn't matter if someone has invested in it, it gets thrown out because newer, better things come along. So one just last piece to underscore the internet of the now. This in many ways is the internet of the now. It is our world with cables on land and undersea strewn together, and we need to make them effectively faster, thicker, have more optimization, have better algorithms. We need to carry more data in order to have everyone spatially connected. This current network is good for text, being frank. It's the simplest bits that we can send back and forth. So I'm just going to dive through these real quick, but I did want to give a better grounding because I know other folks are doing explanations of blockchain, cloud, and edge. So cloud is a thing that took over from bare metal server arrays, and it started, kind of started around 99. It really officially launched in 2002, but it's been the steady growth. And it was right around 2009 when it started to become profitable, and when many of us in companies started to actively go onto it and to put our processes into GPU clusters on it. And then it started to really catch steam in the last decade. Cloud is going to be probably the biggest trend of the next 10 years because there's a massive amount of software and feature functionality that was developed in the last 10 years. There are things that we can do on there that, just to be clear, you can absolutely do in a local array, in a university, in a company. And it is sometimes cheaper to go, I'm going to have this running in a server room. But where cloud is useful is for spinning up massive arrays and having specialized uses where you go, I don't really want to buy 1,000 GPUs, and I don't want them to become obsolete in 2 years. I'll grab an NVIDIA bunch of clusters on G Cloud or one of the others. So there's been this growth. Amazon is the largest, but as you can see, Amazon, Microsoft, Google, IBM, Alibaba, Salesforce, Oracle, Tencent, and a variety of others. The cloud space has taken over bare metal server arrays that we always had around that kind of come out of notions of mainframes and notions of we need to do specialized computing to make things faster. Shifting and actually just to kind of close out cloud, what sits on clouds? The vast majority of video games and the vast majority of virtual worlds and 99.99999% of users that are in virtual worlds are doing that on cloud servers. Even most of the folks that are putting up Web3 worlds are then going and doing that on cloud, mostly on AWS. It's the inevitable. But Internet of Things, streaming audio, streaming video, most of the AI analysis and all of the early XR that we're doing are all sitting on cloud. So where does that bring in edge? Edge is primarily useful, at least at this stage, for things that need low latency, things that need fast response. It's definitely being used in AI. It has a lot of potential in BCI, brain computer interface. For XR to go out of the home or out of the office, it'll need edge. Autonomous vehicles need edge computing. Edge is meant as a supplement to cloud or to other things where it's almost like having a relay. It's having an additional piece along the way. So with that said, I'm going to shift over to what uses the internet. VR is in many respects the first thing because people were doing VR back in the days of mainframe computers. It's important to understand that VR didn't just start in the last bit with like, oh, PlayStation VR and Oculus Quest. VR has been around for basically 60 years, and it's just starting to get to where it's functional now. Meanwhile, consoles started 10 years after VR, and consoles have had 9 generations now, video game consoles. This is where we basically experiment in virtual worlds. Personal computers, which started in the 70s, really effectively launched commercially in '81 with the PC. And these things then led to one of the most important innovations that I'll get into, which is actually the GPU. The GPU, which was coming from things like SGI and Next, that then made possible the commercial video card GPU market that started up in the mid-90s, and at the same time, GPUs going into video game consoles, effectively graphics processors going into homes and being used for real-time rendering of worlds started in the mid-90s. And that's kind of when we set the clock as the race towards the metaverse started here, because we can render it locally on a device and you can look at it. And that was hugely important. Mobile helps, having bare metal servers, cloud, blockchain, all of that. But the GPU is the essential thing, because if you can't render it, it doesn't exist effectively. So games. We won't get into this in great detail, but there have been a lot of games and a lot of game hardware, and games are heavily based on hardware, rendering and running on device. It's effectively the best way to have a connection between a user and a world is the device between them that gives them an interface, that gives them a direct rendering that makes it responsive, and that builds in a commercial understanding of how everyone makes a living doing it. So there have been a lot of devices, and the devices change over time. Who is leading, who is selling, who is running things keeps changing, and that's good. Nobody is permanent. Nobody has a permanent place. Anyone can be upended in the next generation, just as with mobile, just with any hardware devices. But the interesting thing is that Game revenue has also changed and adapted to the devices. What device is selling is never constant. It comes down to what devices work in the marketplace and what do people want to see and use. And so, you see this with arcades taking off initially and then leading to consoles, and consoles leading to greater PC growth, and PC and console balancing out, and then mobile taking over. And we still have yet to see where and how VR is going to fit into this, and how long it's going to take VR. And if VR, is sitting at a place where it looks like some of the adoption in the 90s or the 80s or the 70s, we don't know with VR. But it's probably 20 years away from really hitting the mainstream. But something interesting happened in the last couple of years, and in the pandemic, lots of folks went online and revenue grew. And when revenue grew and more people went online and people couldn't go out as easily because of lockdowns, people started talking about a metaverse. And when they're talking about a metaverse, they were talking about the internet and about all of these things that already exist. And initially, people had been talking aspirationally about a metaverse, frankly, since a year after Neil Stephenson put out his book. We had people dreaming about making the metaverse since the early 90s. But now people are going, oh, this could actually happen because people are going online and we're at this internet peak. How long will it take to get to the next thing? It's always longer than you imagine. And so we've got this growth. And in this growth, people start looking at blockchain, people start looking at cryptocurrency, and they're borrowing terms that come out of, in many cases, games to describe these future things, but we're still really early in making sense of it. And I'm breezing through some of these. The slides will be available for people who want to take a deeper dive. And this is being condensed from 60 minutes to about 20 minutes. So what I would say is that in understanding games and virtual worlds, they're really hard. You go from making a 2D website, and I started as a web designer back in the 90s. Making a website is kind of like making a newspaper. But by contrast, the only thing I can really compare making a game or a virtual world to is it's like, when I would function as a dungeon master in Dungeons and Dragons. It's this process of stitching together a world, but you're doing it in software. And so it's taking notions of world building from Tolkien and others, but you're building out a thing where you go, oh, right, I'm build it and it's kind of up and running. And I built the first 90%, and then we use the 90-90 rule, and you go, right, now you have the other 90% to do when you thought you just had 10% left. Games are always hard. Virtual worlds always take more work than we thought that they would. And that's because of the complexity, where you can't fully understand it until you get it up and running, and then you realize that other 90%. And people sometimes joke beyond that. You've got George Broussard talking about the third 90%. But I'm going to shift from that to what games use, which is the GPU. And this is just a quick overview to illustrate some of these ideas. So the GPUs go back to the 70s, and you had Motorola and IBM making them, putting them into things like the Atari, but also building, in many cases, complex early GPUs that could cost thousands of dollars. That would be thought of as like a workstation GPU these days, but it was in the early days. But that early period led to then things like Silicon Graphics, Next Computers, Sun Stations, and others that were making non-commercial computers for universities, for large groups, for things that were out of the price range of regular consumers. That then changed in the mid-90s when 3DFX put out the first commercial GPU, and ATI, which then was bought by AMD, and NVIDIA came along. And they revolutionized that space by bringing them to consumers. And that created an economy of scale where we could be actually talking about the metaverse now because we were starting to render the early versions of it. And it's important to remember that on the console side, the Nintendo 64 had a GPU that was built by SGI. The early consoles were borrowing from the same places that the PC was. And meanwhile, over on the PC side, you had OpenGL and DirectX coming together to make the process of writing software for this easier so that everyone could write on device and render on device. Now, that then leads to mobile. And this is definitely a thing that has changed the notion of internet because it is now the primary device for people to actually browse and function and interact on the internet. Mobile is, and Qualcomm goes through this, it's a thing that works in 30-year cycles. You look at the mobile devices of the 2015 to 2020 period, and these came out of mobile that was starting around 1995. And mobile is almost at a peak, but mobile's not dying. Mobile, if anything, is like the internet, going to go towards another peak. It's a slow process where people complain year to year, but there's this steady iterative process. But if you look at this iPhone curve, there's this interesting trend of adoption that is similar to internet usage, where it's small, and then it grows on this hockey stick, and then it kind of levels off. And mobile has become the primary computing for a lot of people to experience the current internet, regardless of what part of the internet they're doing. Whether it's they're reading a website, they're playing a game, or doing any other sort of interaction, the vast majority of people are now doing it on mobile because that has become the computing device that allows people to function in its easiest and cheapest form. And that's always essential for getting out to the masses. So mobile grew from iPhone to Android, and Android then began to take over that and showed its own hockey stick. Let me jump over to another piece, which is necessary for this future metaverse, which is virtual reality. And we'll try to wind this down relatively quickly. Virtual reality goes back to the sensorama, this notion of these massive constructions. It goes back to NASA's view and the cave. It goes to the sword of Damocles that would hang from the ceiling, which is why it took that mythical term. Even before we could effectively have components that were small enough, we were building massive constructions. Like I've been over at the Stanford VHIL, where I've seen like their massive helmet virtual reality that you have to have someone holding because it's too heavy to sit on your head. These early ideas of getting you immersed in a world by putting a screen in front of your eyes. That, of course, then led to things like the early Oculus Rift, the Samsung Gear VR, the Google Cardboard, and then this first wave of Rift and Vive and PlayStation to Quest and Pico and Pimax and a whole host of others, including a bunch of enterprise versions. This is wave 5 of virtual reality that goes back to 1956. And it still feels like it's in the early days, and it probably needs the next 20 to 30 years to grow to a thing that can actually reach the mainstream, while internet and semiconductor at the same pace. They all need time. And so just to wrap this up, in games, we've always kind of been going towards the metaverse, but we know that we needed to build early things. So in 2.5D early versions, like Duke Nukem and Resident Evil, 3D versions like Super Mario 64 and Quake, where they were finally hardware rendered. Building open worlds to understand the systems and the streaming rendering to make a massive space for people to go through. Building persistent worlds where the world would have a memory for you after you were gone, which could allow others to be in that space together. So from consistence to persistence, and to building platforms that could sit on clouds and bring people together across different devices. Games have been playing in the space, and things that are kind of semi-proto games like Second Life, as we try to figure out the shape of things to come. And so the path to the metaverse is through games and things like games that build fast and break and try ideas and bring it to bear in the market, bring it to users, set up revenue, but figure out what it can be. What this means is that the metaverse is likely a metaverse on a metanet. We need a new infrastructure that can handle 1000x processing that we don't have yet. We need 1000x data that we don't have yet. But the metaverse is a real-time 3D synchronous multi-user successor to the internet. And if anything, will require that we are bringing spatial computing to connected realities. It's a thing that we have an idea of, but we don't know all the details of. And so just to wrap this up, what are our metaverse definitions? The metaverse should be a thing like the internet for everyone. If it's going to replace the internet, it has to represent a space and a concept for everyone together. And that means it needs to start with community before commerce. You have to bring people in and show them the value before you can charge them or sell them on it. You have to demonstrate value without charging them for that value if you want them to buy into it, because otherwise they don't know that it's worth it. What is it not? The internet is not the current thing. It's not anything current. Everything that we have now will have to be thrown away, just as everything that was on ARPANET was thrown away. The analogy that I like to make is that the metaverse is as close to us as human settlement is on Mars. We guess that we can get there by 2050. We don't actually know. Will we get there? Probably. We'll probably get to the metaverse as well. But it will feel different from the current thing in ways that we guess at, but we don't know all the practical details, in the same way that we don't know what it really will be like to be on Mars with a human settlement. And in the same way that back in the 80s, we really couldn't imagine what current computing is like. We go through iterations, but we lose a bit of the past, and sometimes we have to remind ourselves. And so I'll remind folks that NVIDIA has said that it'll take them about 25 years to get to the point of where they can render anything they want to in front of your eye. Intel has said that to get to what people are talking about for the metaverse, we need 1000x computing. Other folks have chimed in with similar estimates. It's a thing that is a good ways far away, and that's okay. And so I'll leave you guys with a metaverse warning from my old mentor and boss, John Carmack, who he basically said that the obvious path to the metaverse is to build a single thing, and you don't want to do that. You know, any one group that's going to do that is going to be wrong. But John was always very practical. He always focused on building the things in front of him and then figuring out what is possible to build, and then using those things to get to the future. He always looked at the hardware and said, the hardware that we are capable of building controls what we can make in the future, but then let's see what we can build on it. And then what we can practically build is what we will build next, and you build towards that vision. But I love his quote. I have pretty good reasons to believe that setting out to build the metaverse is not actually the best way to wind up with the metaverse. And the other piece of it is that him talking about you have to, you can't just talk about the high level, you have to get into the nuts and bolts. John was one of the best people that I've ever met in terms of understanding the microsecond feel of a thing, that he could sit there and he could guess how many milliseconds it took to do a particular thing, because his focus was how long will it take to render that, to bring that image to the player's eyes. And so his point is that you can get lost as architecture astronauts in abstractions, but you need to know what it is going to be like to feel and to do and to see the next thing, and not the thing that is decades down the road. You always have to build the next thing. You keep that vision, but you do the thing that's ahead of you. And so this is my closing, which is the path to the metaverse is to build community first. You have to build the community now that wants to make the thing. That community creates precursors, which are the stepping stones along that path. And you have to have the vision of where you're going so that you don't get off track. You always have to have these three pieces together. You have to have the people who want to make the thing. They have to make early versions that actually pave that path. And then you have to know that your vision is agreed upon and it is the thing that you want at the end. So that is the history of the metaverse, and that is how you get there. You get there together by building together. But actually, I'll just go back, but it's by not just saying, oh, we have it now, it's by saying we can get there, and everything that we make, we learn from, and everything that we make should get us a step closer, and we can throw out everything that we make because they're all about getting to the final thing, and the final thing is worth it. If you look back in the 80s and you go, we'll have this point where nobody worries about physical media. The point is, if you have a notion in the 80s and you go, how do we get to a streaming future where everyone has access to as much data as they want to, and every text, every image, every audio, or every video is available at the touch of a button? We wouldn't know how to do that. Can you get 1,000 people onto a server and have them play together? Yes, we didn't know how to do that then. We needed all those intermediate steps. And so the whole point is to get to a virtual world that is stitched together, that looks like the movie Belle, which just came out on I think it was HBO Max, but this Japanese animated movie about 5 billion people being in a virtual world together. You can have a vision of that, but the practicalities of that require us to do all the intermediate steps. And they take a long time. They always take longer than we imagine, but they're kind of worth it in the end. And that's the thing that I signed up for when I got out of web design and went into game design, because I was right at that cusp of 3D. I'd been imagining and planning virtual worlds as a kid and as a young adult, as a game designer, on an amateur level for, since I could pretty much walk. I'd always been involved with computers, but there's this transition point where I was doing web design. I was like, this is good, but I'm making newspapers. My passion is making worlds. And then there's this point where I could transition, and I pretty much never looked back. And it was when the worlds could go into 3D, because that's how my brain plans and functions. I envision worlds in 3D, and I basically said, if I can do this, we can get to Tron. If I can make these next pieces, we can get to the metaverse. William Gibson's cyberspace can happen, and I don't know how long it'll take, but I hope to get there before I die. So it's not around the corner, and I'm getting gray, but I think that we can still get there. I know we'll get there, but I think that I'll see it. but I'm not arrogant enough to say that I'll get to it tomorrow, or that I can predict it. But I can predict that we can do it if we sit down and buckle and don't get distracted by other things and go, trading gifts is fun, but can I build a world that is 10 million people moving around together? They don't need to all see each other, but the server needs to see them. Can I have a thing that looks like New York or Shanghai of 10 or 20 million people that are all functioning together? And that's a lot of data, and it's a lot of bandwidth. And to go back to Intel's point, you need to get from 100 milliseconds to 10 down to 1 millisecond. It needs to be instantaneous. And that's what we're trying to get to. And that's the metaverse.
Thank you so much, Raphael, and we appreciate your in-depth review of the history and the vision of metaverse. Thank you.
Thank you.
Yes, I think at this point, I think we should have Sandy take the stage and present some additional perspectives on metaverse.
I'm actually going to go into some of the building blocks. So first of all, hello everybody, this is Sandy Agarwal, and I'll actually just continue from the point where Dr. Ozar just kind of laid out a brief introduction to what the core definition of metaverse is, and how we can think about metaverse being slightly different from just Web3 and blockchains. So let me just continue from here. And you can let me know if you can see my screen. Okay, so when we talk about the different building blocks of the metaverse, it's important to understand that we can differentiate the metaverse from just the game devices or just the underlying blockchain or the game or the Web3 engine. So we're going to be covering a bunch of topics here, but again, this is supposed to be just a quick orientation session. So we're not really going to go into too much details of any of these things. We'll purely just touch upon these different points here, and then in the subsequent sessions, we're going to have more details about each one of these subtopics. So the listing you see here is basically what are all the different components that actually really make up the metaverse. So we have, I'm actually going to go to the next slide, which shows like a bunch of different things. Of course, we're all familiar with different AR, VR, MR devices. Obviously, I think some of the most popular ones being MetaQuest or Oculus, which is part of the Meta or the VR department from Meta, which is Facebook. And you have Microsoft HoloLens, which is one of the most popular AR/MR devices. It's not commercially, or it's actually it's not really used on a consumer basis yet, but it's more commercial usage. And of course, you have Valve Index being another VR device. But the reason I bring this up is that, like actually Dr. Ozar mentioned in her opening remarks, that there's a lot of confusion when people think about metaverse. The first image that comes into their mind is basically pretty much something like what you see here. It is somebody just having a strapped-on device and they can just get into the metaverse. But the metaverse is much more than just strapping on a device and much more just a game or the underlying Web3 engine. So the way I think about the different building blocks of the metaverse, basically, I like to divvy them up in infrastructural or core hardware components. And I'm going to come back to this slide in a second. And the applications and software, the bridging components that actually kind of glue things together. And finally, the centralized versus decentralized debate for the metaverse. And we're going to go and take some specific example as to which we'll go into after this slide. But let me just come back in here for a second there. So when we talk about the infrastructural core hardware components, this is where the devices, all the core devices, these are the machine to human interface, which is necessary to experience the virtual worlds. Now, however, these devices we still have today are not commercially and then practically useful. Basically, I say commercially viable in the sense that they're not something just like you can go buy a cell phone. It took a good 10 or 20, or in fact, say more than 20 years before cell phones came to the point, or the mobile devices came to the point they could be practically useful, where you can use them for more than just as your pages, or basically they will not like have a point of break. So it has to, any of these devices have to become lighter weight. They have to become non-intrusive. Nobody can expect to stay in the metaverse for hours and hours by strapping on a multi-pound device on their head and being in there for many hours. Game engines and virtual worlds. Now, I believe it's a pretty commonly agreed upon concept that while metaverse is not just gaming, but metaverse will definitely start with gaming first. And what we mean by that is basically is the initial focus, most likely, of course, there's no metaverse yet. We can't really call some websites metaverse yet. But whatever the new version, the initial version of metaverse comes in, that will be most likely some immersive gaming in virtual worlds, as Dr. Ozai was also mentioning earlier. And that's going to be followed by communities and business/work. Now, this is where the game engines, whether that's Unreal or Unity, of course, the two most popular ones, of course, there's Amazon coming in there, there's CryEngine, and then, of course, there's multiple popularity ones from Activision and Steam, which they have for all their own games, but only from the biggest of the studios or the biggest of the game developers. So there's a whole bunch of different game engines, which are going to be the crucial elements in creating these virtual worlds. And if you just go down the list here, so obviously the computing power. As we know right now, the computing power we have on our devices or on our cell phones or mobile devices, or even the VR and the AR devices, is enough to get us intrigued, is enough to basically give us a good glimpse into what it could be if you have to get into a virtual environment. But it's definitely not enough to have an always-on virtual world where you can just be in there with multiple, or I would say hundreds or even thousands of concurrent users. We do have some, obviously that we have the MMORPGs, which are the massively multiple online RPG games, or other kind of games, but none of those are fully immersive, and none of those are fully always-on kind of environment. Now, obviously, in this list here, we have networking and bandwidth. So this becomes one of the most critical things, because whenever we talk about being an immersive environment, you cannot have an immersive environment unless you have the bandwidth. So even if you're just trying to download a game today, and if you're playing something on the cloud game, you cannot expect to have a completely latency-free game if you don't really have very high bandwidth and then high Wi-Fi speeds and all that. So this is where your bandwidth, in terms of the how much, whether it's 100 Mbps or it's 1 gigabyte speed, you can enjoy, or in some of the places you got to be able to do with a much higher latency. So there are certain games, for example, I think this is something I like to dive in a little more, is like, if you are thinking about being in the metaverse, and if you, for example, if you are thinking about even having a racing car game over there, you cannot adequately enjoy the game if you have anything less than 60 frames per second. And most of the newer games and most of the newer virtual worlds are expecting higher latency than that, or basically I say lower latency than that, and higher speeds to really make a meaningful impact on the user experience. And so essentially networking, which includes bandwidth and latency, becomes one of the core components of the core infrastructural aspects of the metaverse. And of course, then we have the data storage, because even though we just download some basic games, we download some basic virtual experiences, you need to have tons and tons of space on your hard drives. And then, of course, if you're talking about something like, let's take an example, like say a Microsoft Flight Simulator, which needs to basically have a much more granular level of details for everything that you're trying to render. You cannot simply have just a few hundred gigabytes. This goes into much more than that. Literally goes into petabytes, and then the question becomes, who really has the capability or the capacity to really have that kind of data on their local devices? Now, of course, you can have this kind of data on some cloud infrastructure, but then that's where the networking comes back into the picture as to, can you afford to render really high quality virtual worlds without introducing a lot of delay and without really going high in your FPS limits? Basically, you cannot reduce the frame per second if you have to really deliver that kind of content to the end user's device. Now, once we have gone over the core components, we'd like to go into the applications and the software that really do the bridging. And this is where a whole bunch of other things come to play, which include the payment systems. And the reason I even bring this up here as one of the first things is because anytime we talk about whether it's the game systems, whether it's the any sort of a virtual world, as anybody might have done at any level of gaming, they will know that you need to have you need to engage with the gaming ecosystem. You need to engage with the other people playing the games, and all those will require some sort of payment systems. They'll require some sort of a commerce, whether we call that the e-commerce or the re-commerce, whatever that, or even the m-commerce, whatever that comes to be known as. There will have to be some sort of mechanism to establish payments between the players and the participants, and it will have to be in such a way that it's not exploitative, and also in such a way that, of course, you cannot have a currency which is $1 today and then $100 tomorrow, because that's not something which is either going to be useful for the regular players, and B, nobody would be able to basically keep up with that kind of fluctuation in the actual metaverse. So then, of course, you have these social networks to be able to form communities between like whether you're forming a community within your own virtual world or you're forming a community across virtual worlds. There will have to be social networks. And again, this is also debatable as to whether you want to have the social networks, which are an extension or something like today, whether there's Discord or Twitter or something else, or there's a social network which is completely decentralized, which is a big conversation going on, and who really gets to have the ownership of data on those social networks. So like Dr. Ozai mentioned, there are no more happenings like Cambridge Analytica, where somebody can just take your data and just sell it out to somebody else. So now, for all these things to work, this is where the interoperability and of the systems and processes comes and becomes a big central thing in this whole thing. Now, when we talk about the interoperable aspects, we have to keep in mind that it has to be not only within a given virtual world, but also across the virtual worlds. So just to give an example, basically, let's say, again, in the context of gaming, you can have a game like, say, Second Life, or you can have people who are on Roblox or Fortnite or somebody else. Now, are these people able to, basically exchange assets with each other? And are they able to communicate with each other, not just via regular text, but basically within the metaverse? So the concept of interoperability is much more extensive, is very debatable, because the very core premise of the typical Web3 mindset is that, oh, you can take a given asset from a given game and you can basically just use that in another game. But as we all know, that's not something you can do that easily. Any given digital asset from a given virtual world or a given game is not something we can use easily, just ship it across to another game or another virtual world and use without consequences. There's many layers of complexity over there, which has to be resolved. And basically, I'm just gonna make sure, just check on the things. There's many layers of complexity, including legal, including how you really like how one virtual world or one given game really understands the details of that specific asset. So you cannot really basically just take a scan or even a character from a given game and just make it work in another game or another virtual world. So unless all those standards have been established, but again, then if you just establish a whole bunch of standards where everybody basically has to follow the same standards, then you essentially end up losing the uniqueness of all the virtual worlds, and then you all you have is basically a plain vanilla standardized kind of like a cookie cutter sort of thing, where there's no distinction between one virtual world versus the other one. So basically, in a sense, there's a lot of complexities when we talk about the interoperability of digital assets, and that's going to be a pretty big topic in itself. Now, artificial intelligence, this is generally speaking, is not really talked about a lot when we talk about the metaverses, but this, again, Dr. Oza touched upon this too, but this is actually a double-edged sword here. So sorry, going back here. So the artificial intelligence is actually a double-edged sword here, because on the one hand, artificial intelligence comes in very handy in terms of creating more bots and creating interactive NPCs, which are non-playable characters. That's how a lot of virtual worlds and gaming engines actually enhance the user experience when they have other characters in there. But at the same time, with the GAN networks and with the deepfakes, AI is actually bound to be one of the biggest dangers. Like if with the unbound and unethical use of AI, that's actually one of the biggest concerns a lot of people on the who are on the guard in terms of how things are going to go in the metaverse. That's what they're looking at. I'm going to go on here, try to cut down a little on my details. So another big thing that comes in here is basically the whole concept of that and the whole debate in terms of centralized versus decentralized. So I'm not really going to go into each and every detail here, but at the high level, whenever we talk about the centralized and decentralized, this is where this becomes a very contentious topic, because on the one hand, there's a lot of functionalities and features you actually get from the use of blockchain and the decentralized frameworks and the decentralized processes. Just to name a few, SSI is, yes, technically speaking, you can attain self-sovereign identity without the use of blockchain, but blockchains lend a very big helping hand to the use of SSIs and other features here. Now, why is that important? Because unless we have self-sovereign identity, you will have to somehow lean on some sort of a central authority to basically have identity like an authentication be implemented in the metaverse, and that's not something, as a decentralized thing, that's not something where we want to be, because then essentially you end up giving all the control to some central authorities. So that's where Web3, or I should really say blockchain, comes in and it becomes an important part of implementing SSI features. Now, NFTs, in fact, I'm going to touch upon this in a moment. Obviously, we all know about NFTs and non-fungible tokens, but leaving aside all the hype about the NFTs and all the negatives and everything else, but basically NFTs do provide you the digital provenance for the underlying asset, and that's where this becomes a very key feature. So if you think about the NFTs, in fact, I'm going to have another slide on this in a second. I think I should probably just go down here for a sec. So the different kind of NFTs, as we all understand that, there's art, collectibles, and in fact, you can think about this, that if you're in a virtual world, pretty much everything that you deal with is going to be some sort of a digital asset, whether that's art, whether that's your avatar, whether that's the digital land which you own in the metaverse. But the ownership of that specific asset is going to be proven in a way by the NFTs, and also the provenance of the ownership as to who exactly owned it, whether that's single ownership record. That's really going to be proven by the NFTs. So that's where the NFTs actually become useful, but not necessarily in the current way they're being used in the hype, not necessarily by imposing artificial scarcity, but by making use of the actual ownership record on chain. Now, I'm going to have to come back on this for a second, and then we're going to go into more details of that. So obviously, then we have DAOs, which is the decentralized autonomous organizations. Now, this is something which gives you community ownership. Again, given the time today, we're not going to go into details of this today, but we're going to talk about this in more details in the upcoming sessions. dApps, which are decentralized applications. These are the applications which are running on blockchain, and they allow open source and openly audited source code to be running processes and applications where you don't really have to depend on a given company or a given a developer, basically to just be bound to their specific application. And the application is openly running and is basically, in a way, is unbiased and is open to everybody at once, for everybody the same way. And of course, we have decentralized finance, which removes the dependency on central or government institutes, but of course, then it adds much higher risk because of the removal of the intermediaries. I'm going to move into the next session here. Just keeping an eye on the questions and timing. Please do let me know if there's any specific questions here, but I'm going to just keep moving on here as a specific example. So let's talk about the specific example here. So we spoke about the NFT. So I'm going to take a specific example here. So obviously, I guess everybody knows about the BYC or the Bored Ape Yacht Club. So let me take an example here. So let's say if you actually owned one of these assets. Again, forgetting about the hype here, forgetting about everything else. But the way you can think about this is that if you own a digital asset in the metaverse, the way the underlying use of blockchain becomes important here is because a given asset can be proven based on the contract address here. You know exactly who's the owner, and of course, in this case, there's a name assigned to this because of the DNS system or the naming system on Ethereum. However, like Dr. Ozai also referred to, the ownership and the ownership data here is pseudonymous. Basically, you may be able to see what is the contract address or what is the ownership address, but you may not be able to, unless you have some other related information, you may not be able to see exactly who owns that. However, as long as you can somehow cryptographically prove who's the owner of this, there's an immutable and an indisputable proof as to who owns this given asset and what exactly is the full history of this ownership, and what kind of token is this, and what data is, and all this kind of things. And of course, in this specific example here, you see the price of this thing. You can see the token standard. In this case, it happens to be ERC 721. Again, more details on this later, and which marketplaces this specific asset is available on. I'm going to go further down here. I'm going to actually skim through this here, but the reason this becomes important is because when we talk about the underlying blockchains which are hosting the ownership information, it's important to understand that there's not only one kind of blockchain, there's multiple kind of blockchains, but primarily there are two categories. There's permission blockchains and permissionless blockchains. So obviously Ethereum and then Solana, Cardano, all these guys, they fall under the permissionless, where anybody can basically just start using them. They don't need permission from anybody else. But the permission ones, of course, Hyperledger, Coda, and a bunch of other ones, they fall under the permission ones. So one of the big debates which is going on in the Metaverse universe is whether it should be running, or what kind of assets should be on the permissionless blockchain and what kind of assets should be on the permission blockchains, because there are pros and cons in both sides. In general, as a thumb rule, anything permissionless is going to be, generally speaking, slower, and obviously more open data. You have no way to basically hide data here because everything is up on the chain. In permission blockchains, there's different shades of data openness, and you can basically hide some specific kind of data. You can have different kind of channels which can hide data, and you can assign rights to who can see what kind of data. So there's an ongoing debate as to where the data should be in and how much data should be on which kind of chain. Going to come to one of the last important aspects here. So whenever we talk about the blockchains and the data, I find this thing to be a very important aspect here, that we need to look into the blockchain trilemma, which I believe have all heard about, of the blockchain trilemma of decentralization, security, and performance versus scalability. And also something which we probably generally, like outside the technology circles, wouldn't really talk too much about is the data triad of confidentiality, integrity, and availability. And it's a critical aspect that whenever we talk about the data in Metaverse or on blockchains, we try to balance these two aspects together. And let me explain this with a couple of quick examples here. So whenever we talk about the trilemma on the blockchain side, I guess anybody who has been studying blockchains or looking into this aspect, they understand that you have like any data on the blockchain. Of course, there's a whole concept of decentralization. The whole point about the blockchains is that you need to have decentralization. You cannot have centralized authorities or entities owning the data and having entire ownership of the processes of the data. But on the other hand, if you have decentralized processes, you have the whole idea. In fact, let me please go back to this, that when Dr. Ozar just mentioned that, think about the blockchain as a distributed ledger. So essentially, when we talk about a blockchain being a distributed ledger, essentially it's a database where everybody who's a participant has a copy of that ledger or the database. But if you have 100 people who have a copy of the database or the ledger, how do you really prove who has the right copy? And that's where the consensus mechanisms come in, and then that introduces the scalability issue, because in order to achieve consensus between the participants, you need to have all the participants or the majority of participants have some kind of consensus, and if you have really a wide open network, it becomes very hard to achieve scalability. And of course, if you reduce scalability, if you only have very few people doing the consensus, that's where you would introduce a security risk. Prime example being Axie Infinity. I'll again share some examples in maybe after this call, but like if you reduce the number of people who are participating in consensus, then your system gets compromised and you have a very high attack risk. That's exactly what happened in the case of Axie Infinity just a couple of months ago. So how does that relate into confidential integrity and availability here? Because anybody who has worked with data knows very well that even if you're just working in a single environment, achieving confidentiality of the data and the integrity, which means the data is secure and is fully proven to be completed and is available when we need it at scale, that becomes a challenge even if you're just running a single organization. Now think about this: if you have to have data in a distributed and decentralized environment. So with those thoughts, I'm gonna wrap up my points here. But this is what we're gonna dive in more details in our subsequent sessions, and we are gonna have more questions coming up. So let me see if there's any open questions at this point.
Thank you.
And,
thank you, Sandy. Thank you, Sandy. I think there are some questions. Tainisa, would you read the questions?
Absolutely, Dr. Imdad. So the first question was basically asking, can you send the slides to the audience? They would like to see your presentation.
Well, absolutely. So, well, I think we'll compile these slides together and share with everybody after the webinar. Yes.
And then the next question is, what are the opportunities for students in your organization and in the metaverse?
I I can take that on very briefly, but I think Dr. Ozar can actually also definitely chime in on that. But let me just give a very quick 30-second answer on that. So basically, I think one of the things we're trying to bring in as part of this session of webinars is, or series of webinars, is to highlight that there are multiple areas and multiple disciplines within the metaverse. And so with all those multiple disciplines, there's a lot of opportunities for anybody who's interested in basically being a participant in the metaverse economy. So whether that's in the graphical side or whether it's in the being a blockchain programmer or just even in the fintech side of it. But let me hand this over to Dr. Ozar to add some more color to that.
I don't really have much to add. I mean, all what I'm saying is that, the metaverse, as I said, it's not a concrete concept right now. It's not a concrete reality right now. But there are a lot of jobs out there that kind of leading towards that, whether it's development, whether it's business development, whether it's programming and all of that I've seen that are now, trying to put things together. That's how you have to think about the metaverse at the moment. There's no jobs per se for the metaverse. It's just maybe things that are leading towards that, and this is how you have to think about it. And whether it's in the blockchain space or the NFT space or the DeFi space, and the business, as I said, business development, you can find jobs that are relating to that, because as we progress and develop, we need people to help us think about all this development.
I think one quick comment is many of the companies that are in the forefront of technology, for instance, Accenture, is one of those such companies, and they have something like 250 proof of concept projects they have developed in that area. Over 600 patents have been registered in the areas of related to metaverse. And in terms of use cases and in terms of applications, advertising is a prime area where companies are taking advantage of that, including Meta is using that. You can see some of that already being pushed to the users, and universities are getting into that area. As Sandy pointed out earlier, there are some universities, for instance, are offering their courses, some in Japan, some in the US. They're offering their programs in the metaverse. So change is happening. A lot of things are coming this way in the technology arena. And people are really being innovative, and they use their imagination. So with that, I know that we're past our 1 o'clock time frame. Many people expected this to be more detailed, but unfortunately, in the limited time that we have, we can address and touch the surface, so to speak. In the future sessions, we go a little bit deeper. We discuss a lot more topics and issues, but I wanted to thank the panel, outstanding panel that we had today. And also I want to thank Hyperledger for their support and connecting us with the community. That has been phenomenal for us. And of course, our Ripple sponsor that they have been the Genesis sponsor for the FinTech Center, and we want to thank him as well. We're in a new era of digital change, and so I want to invite you to start the journey where change, imagination, and opportunity meet. Until next time, thank you, be well, See you in the next session.
Thank you.
Thank you very much, Dr. Imdad and Tanise, and of course,
Thank you.
Dr. Ozar.
Thank you,
Nice to meet you.
everyone. Have a great